Now we will practice the question number 4. How many 5-digit telephone numbers can be constructed using the digits 0 to 9 if each number starts with a 67 and no digit appears more than once? Here we need to construct 5-digit telephone numbers. It means we have 5 positions. To fill these 5 positions, we have digit 0 to 9, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 10 distinct objects to fill these 5 positions, and we have few constraints. Each number starts with a 67, so we are only interested in those 5-digit telephone numbers that starts with a 67. So these first 2 positions are taken and no digit appear more than once. So in this 5-digit telephone number, we do not expect any of these digit appear more than once. So 6 and 7 cannot appear again here. It means 6 and 7 are taken, and we have remaining 8 objects to fill these 3 positions. So using the remaining 8 objects, here we can have 8 different variations, and once a particular object is assumed here, we can have 7 different variations here and then 6 different variations here. So the total number of variations we can have in these 3 positions are 8 multiply 7 multiply 6, and here we cannot have any other variation because this particular position has to be filled only one way, which is there is only one option to fill 6 here, and then here 7, there are no other variations applicable. So if we multiply these numbers, we get 8 into 7 into 6 equal to 336. So this is the answer. We can have 336 5-digit telephone numbers starting with a 67 and using 0 to 9 only once. Another way to approach this question is, here we have n objects and r positions. In our case, n is equal to 8 different objects to fill in this position, so n is 8 and r is equal to 3. So when we create permutations from n objects taken r number of objects at a time, we can have npr permutations. Here npr can be expanded to n factorial divided by n minus r factorial. In this specific case, n is 8 because we have n distinct objects, that is 8 distinct objects, and to construct the number we can take 3 at a time from 8. So n is 8 and r equal to 3. N factorial is 8 factorial and n minus r is 5, and 8 factorial divided by 5 factorial. This many permutations can be created from 8 objects and with 3 positions. 8 factorial by 3 factorial is 6 multiply 7 multiply 8, and that's equal to 336. This is another way of approaching the same question using the equation of permutations, n factorial divided by n minus r factorial, to calculate the NPR.